Greetings again everyone, welcome back to my channel. Here we have another algebraic exponential equation that we are going to solve. In this equation we have x to the power of x is equal to 25 and we are given to find the value of x. As usual, you can pause this video and see if you can do this one by yourself. If not, stay to the end of this video to see how to solve this equation. You may also take the time out to see my math playlist on how to solve other algebraic exponential equations like these ones. Alright, so let us look at our problem. We say that we have x to the power of x is equal to 25. And in solving this equation, we're going to be using a special kind of function called the Lambert W function. Now this function is used to solve equations where we have x in the power and also x in the base. In this case, we have x to the power of x. The aim is that we need to write this expression in the form of a times e to the power of a, and then we apply a w function to this expression and the result will just be a. So where we have x to the power of x, we're going to write it in the form of a times e to the power of a. We start to do this by taking the natural log of both sides of this equation. So we have ln x to the power of x is equal to ln 25. And now from here, we'll be looking at this logarithm rule, where it states that if we have an expression where we have ln x to the power of y, it is the same as saying y times ln x. Now we can use this expression to apply right here. So then from here we apply our logarithm rule. So we have x ln x is equal to ln 25. And now from here we write x in the form of e, in order for it to reflect our e in this expression. And so to do this, in writing any number in the form of e, we say e to the power of ln that number. So in this case, x is equal to e to the power of ln x. So we'll be replacing x with e to the power of ln x. So then we have e to the power of ln x, which is actually x, times ln x is equal to ln 25. Now let's see what we have. Now as we are writing our expression in the form of a times e to the power of a, if we look in the power we see ln x, and in the base we also see ln x, and in between that we have e. So here we have a in the base and e being raised to the power of a. This therefore means that we can apply our w function to our expression. So we apply our w function to both sides of this equation. So we have w of ln x times e to the power of ln x is equal to w of ln 25. Now applying our w function to the expression a times e to the power of a, in this case ln x times e to the power of ln x, we know that our result is just a, which in this case is ln x. So then this therefore means that we will now have ln x equals w of ln 25. And then from here we plug this into our scientific calculator. So we plug w of ln 25 into our calculator, and our decimal approximation to 4 decimal places is 1.0863. So then this means that ln x is equal to 1.0863. So we continue to solve x by taking the inverse of our natural log, which is having x being equal to e to the power of 1.0863. So we say that x is equal to e to the power of 1.0863. And so from here we can plug this into our scientific calculator. So here's my calculator. Let us put our values in and see what we get. And there we have it. To 4 decimal places, x is equal to 2.9633. So again, we said that x is equal to 2.9633. We can verify this solution by doing x to the power of x in our calculators to see if we get 25. So we say 2.9633 to the power of 2.9633. Let's see if that equals to 25. And there we have it. Our solution is verified. The value of x is approximately 2.9633. Now, thanks again for staying tuned with me to the end of this video. I hope that this was very informative. Please remember to smash that like button, share and subscribe to my channel to see more math videos like these ones. And until again, I'll see you again soon. Thanks again and take care.